Take you through the solving equations worksheet, looking at the key, kind of just take some time and describe how I would solve all these equations. So let's just start with number one, x plus 3 equals to 12. And so I want to use the inverse operation of addition, which is subtraction. And really what I'm going to do is I'm just going to subtract 3 from both sides of the equation. If you have x plus 3 and you subtract 3, you're going to have just an x on the left side, and then 12 minus 3 is 9. I'm not going to show every one of these steps, but I'm going to say what I do. So this is x plus 3 equals to 12, and then the next line is x equals to 9. Again, the property of an equation, meaning how an equation works in math, is that you can do the same thing to both sides of the equation. You can multiply both sides of the equation by 5. You can subtract by 7 both sides of the equation. You can add 10, right? An equation is a balance. Right? The left side equals the right side, and in this case, you pick what you do based on the equation. Okay, so over here on number 2, I have 4x equals 24. Well, 4x is really 4 times x. So I want to get rid of that multiplication, so I'm going to use division. So I'm going to divide both sides by 4. 4x divided by 4 is just an x, right? The 4 and the division by 4, they're going to undo each other. A lot of people use the word cancel. But they're really inverse operations. And then 24 divided by 6, or 24 divided by 4 is just 6. So you get x equals 6. So this is the solution to this equation. It's a solution because if you plug that x value in, 4 times 6 is 24. 24 equals 24, and you get a true statement. If you plug in any other number than the solution, then you get a false statement, right? X, if you thought x was 10 here, 4 times 10 equals to 24. No, that's not true. That's a false statement. So that would mean that 10 is not a solution to the equation. Here, okay, I'm going to do, can I scroll down? I have to do, okay. So on number 3, I'm going to add 5 to both sides and get 14. Number 4, I have x divided by 3. So I'm going to multiply by 3, right? The addition with subtraction, multiplication with division, right? They're inverse operations of each other. Okay, so I'm going to multiply both sides by 3 and get 15. Again, you can check your answer. I would say probably mentally you could just mentally do the first one, right? You're asking what times 4 equals 24, right? 6. You know, what minus 5 equals 9? Okay, I need to be 5 bigger than 9 then, so it's 14. All right, now this one is finally our first two-stepper, right? 1 plus 3x equals 19. Well, in your head, you're saying, well, 1 plus what equals 19? Well, this thing must be 18, right? 1 plus 18 is 19. Well, then if this is 18, 3 times what is 18? Well, 3 times 6 is 18. So then we get an answer of 6. Algebraically, what you're doing is that you're going to subtract 1 from both sides, and then you're going to divide 3 by both sides, and then you get the solution. And again, you can check your answer. So you can do it mentally or you can do it algebraically. Okay, let's scroll up and look at 6. In this case, you have to remind yourself that right there, x minus 2, those are really with parentheses. They're not going to have parentheses, but the top of a fraction, there are parentheses. So you have to deal with a 5 first. The 5 is dividing. So what you're going to do is you're going to multiply both sides by 5. So it's going to get rid of the dividing by 5 here, and it's going to make this 20. And then I'm going to add 2 to both sides and get 22, and you can check your answer, right? What divided by 5 is 4? Well, 20. And then what minus 2 is 20? Okay, 22. Okay, here I'm going to divide by 3 first and get 7, and then I'm going to subtract 2 from both sides and get 5. Again, what you're doing when you're deciding on the order here is you're basically doing the reverse order of operations, right? You're getting rid of things. You're trying to isolate the x. You're trying to solve for x. You're trying to get x all by itself. And so we want to get rid of the 3 first, and then we'll deal with the 2. Over here, we're going to get rid of the 6 first by subtracting, right? This is a positive 6, even though there might not be a sign there. And then I'm going to divide by a negative 5, right? 20 divided by a negative 5 is negative 4. And again, this is negative 5 times x, right? Negative 5x is negative 5 times x, so I'm going to use division. Over here, this is 3 steps, right? I'm going to get rid of the 10 first and subtract by 10, because remember, this is a positive 10 over here. And then I'm going to divide by negative 2. because negative 2 times this. You could have distributed this and done it in a different order, but this will actually be the easiest way is to get rid of this negative 2 by division, right? This is a multiplication sign there. And then I'm going to subtract 4, and I get x equals 0. Remember, x can be 0. X can be anything it wants to be. In this case, x is equal to 0, right? 4 plus 0 is 4. 4 times 2 is 8. 10 minus 8 is 2. Perfect. Okay, 10. Again, do think about the reverse order of operations. I'm going to get rid of the 3 first, so I'm going to subtract by 3 and get this. Then I'm going to multiply by 5, right? This is dividing by 5, so I'm going to multiply by 5. Then I'm going to add 4 to get rid of the subtraction by 4. And again, feel free to check your answer. Okay, now here we actually start to have x's on both sides of the equation. Right? Up here, x was only in one kind of spot, so we just wanted to isolate the x. Now when we get to number 11, we're going to get x's on both. We're going to have x's on both sides of the equation. So what I'm going to do is I'm going to combine like terms. I'm going to get all the x's to the right side and the constants to the left side. So I'm going to subtract 3 from both sides. Hopefully you can see that if I have 5x and I subtract 3, I have 2x. And I'm going to subtract 12 to this side of the equation. 4 minus 12 is going to be minus 8, or negative 8. And then I'm going to divide by 2 and get negative 4. Again, this is me combining like terms. X's with x's, numbers with numbers. 12 is the same thing. I'm going to subtract this x over here, so I'm going to move this 1x over here. All right, subtract it, and I'm going to only have 5 x's then. I'm going to add 5 to this side and make this 20. And then I'm going to divide by 5 and get 4. Okay. 13, I'm actually going to have to distribute first. I got a whole bunch of terms here, so I'm going to distribute this 2. Remember, distribute just means multiply. Okay, so I'm going to multiply the 2. 2 times x plus 1. Minus 4 is just going to chill. 5 is going to chill. And then I'm going to multiply the 3. 3 times 2x is 6x, and 3 times negative 5 is negative 15. Now I'm going to combine like terms. Right, so I did the 2 and the negative 4 to give negative 2, and the 5 and the negative 15 to get negative 10. And then I'm going to do what I did in 11 and 12. I'm going to combine different sides of the equation. So I'm going to subtract 2x over here. I'm going to add 10 to this side. And again, 6x minus 2x is 4x. Adding 10 to negative 2 is going to give me 8. And then I'm going to divide by 4 and get 2. Okay. Now, the rest of these, well, actually, no, we should be able to do the fractions. For the rest of these might be a little more advanced for the beginning of geometry, but these are things you did in Algebra 1. So on 14, what I did is a lot of people are going to say cross multiply, but really what you're doing is you're doing the same thing you've done this whole time. You're just using inverse operations. You're getting rid of this dividing by 27, and so you're going to multiply. See how 27 is dividing on the right side? So you're going to multiply by the left side. And this is dividing by x, and so you're going to multiply it to the right side. So this x is going to multiply by this x and give you x squared. The 27 on the right side is then going to multiply over to the 3 and get 81, and then you're going to take a square root. And I just wanted to remind you that if you have like 81 equals x squared, when you take the square root, you have to introduce the plus or minus, which you would have learned in Algebra 1. Right? Taking the square root, you have to account for the positive and the negative. This one, I'm going to go ahead and subtract 3. And then I'm going to take the square root of both sides, and I'm going to end up with that same thing. The plus or minus the square root of 16. The square root of 16 is 4. So you're going to get plus or minus 4. So 14 and 15 are kind of quadratics where we're going to use square roots. 16 certainly is something you have to be able to do. You have to be able to work with fractions. In this case, I'm going to look at the lowest common denominator. All right? If my denominator is 2 and 3, I'm going to multiply everything by 6. I'm going to multiply this by 6, this by 6, and this by 6, and that will give me this next line, right? 6 times x plus x over 2. Well, 6 divided by 2 is 3, and I'm left with 3x. 6 times 4 over 3, 6 over 3 is 2. 2 times 4 is 8. And then 6 times 5 is 30. And then I'm going to solve like normal. I'm going to subtract 8. And then I'm going to divide by 3. And in this case, you get a fraction answer, which is nothing wrong with that. Okay, I wouldn't worry about the rest of these. They're not going to come up very often. 17 is that you're actually going to square both sides at first. Right? You're going to get rid of a square root by squaring. Just like you get rid of addition using subtraction, or you get rid of division using multiplication. If you want to get rid of a square root, you have to square both sides. 18, don't worry about. That's got a fractional power. I mean, you can look at it if you want, but that's kind of a challenge. 19 is factoring a quadratic using double bubble. If you remember, this is you're looking at the factors of negative 12 that have a difference of 1. Again, this was an Algebra 1. You can do it. And then 20 it was just an example where there is no solution, right? 3x equals 3x plus 10. Well, there's no value of x that's going to make this a true statement. No matter what you do, you're going to get a false statement, and so you're going to get a no solution, which just is a reminder that there's not always a solution. Again, you should really focus on, maybe the first 13, but we will very shortly get to situations where we have quadratics like 15, where we use square roots, or quadratics like 19, where we use the double bubble method, or factoring out a greatest common factor, or factor by grouping. Again, hopefully this was an okay review of Algebra 1 and solving equations.